Okay, guys, in this video, we are going to take a look at a polynomial that is already in factored form. And so you should be able to figure out what is the end behavior. In other words, how it behaves at positive infinity and negative infinity. So I have here x plus 4 cubed multiplied by 4x minus 9 and multiplied by x plus 2 squared. Okay, so in order to figure out, first of all, what is the leading coefficient and the degree, you want to discard the numbers inside each parenthesis because they're not going to matter at large values of x. So you can just think about crossing them out and only leaving the x's there. So if you do that, you're going to get x cubed. You're going to also get multiply that by 4x and then multiply that by x squared. So when you find in the degree, you want to add up the powers of x if it's in this form. Now, x itself is x to the power 1. So don't worry about the 4 in the front. That's not going to affect the degree. What you're looking for is the powers of x, and the degree is going to be the sum of those powers. So the degree would be 3 plus 1 plus 2, which is going to be 6. Okay, so I know that this is a 6-degree polynomial. Now, in terms of the leading coefficient, you're just looking at the numbers, if any, in front of x and multiplying them. So I can see that only one term has a number in front of x, and that's 4. So that's going to be my leading coefficient. So that's going to be a 4. So once I determine that, I should be able to figure out the end behavior. So how do I do that? Well, here I have 4 graphs, and I want to discuss how they behave when x goes to negative infinity and when x goes to positive infinity, which is called end behavior. Now, it depends on, first of all, the degree. Is it even or odd? So for this picture that I have on the top left, this is where the degree is even. So something like x squared, x to the 4th, x to the 6th, and so on. And then the leading coefficient is positive. Okay, so here the leading coefficient is positive. Okay, so what do I see happening for this kind of case? And I want to know what happens when x goes to negative infinity and what happens when x goes to positive infinity. What happens to my f of x at that point, my graph? All right, so how do I determine that? So imagine that you are moving towards negative infinity. So you are going this way, okay, forever, without bound. At the same time on the graph, as you're going, so your x values go to negative infinity, what is happening with the y values? So you can see that they are going up towards positive infinity, because positive infinity is on the top. Like this is positive infinity here, this is negative infinity. So that means that this is going to go to positive infinity. Now, if you're going the other way, so if you're going this way, okay, what happens then? So let me see if I can maybe use this pen. Okay, so this is where it like goes as you're moving to the right at the same time as you're walking on the curve. You're going to be approaching positive infinity, right? So this one is positive infinity. Okay, for the bottom one, which is the reflection, right? You could just flip it over the x-axis. What is happening? So here again, the degree is even, but the leading coefficient is negative because you're flipping it over the x-axis. So leading coefficient is negative. All right, so what's happening now? Again, you are going this way. As you're walking on the curve, you're going to go down to negative infinity. So negative infinity is here on the bottom. And then the same exact thing will happen if you're going this way. You also will go to negative infinity, right? Because this is where you're walking, walking, walking. Let's see. And so it's going to go to negative infinity, okay? So then let me just write that down. So the x approaches negative infinity, f of x goes to negative infinity. And if x approaches positive infinity, f of x is also going to negative infinity. Now, what about the odd cases? So if the degree is odd, and leading coefficient positive, what is happening then? So then what happens is, let's first take a look at what happens at negative infinity. So if you're walking this way, at the same time on the graph, where is the graph going towards? So the graph goes towards negative infinity because that's on the bottom. So this is where f of x goes to negative infinity. But if x goes to positive infinity, so if you're going this way, so on the graph you're traveling up to positive infinity, that's where that is, right? So this is where f of x approaches positive infinity. Okay, and finally, the last case here I have is degree is odd, but you are flipping it over the x-axis, so everything flips, right? So here the leading coefficient would be negative. Negative. So here I would say if x approaches negative infinity, f of x approaches positive infinity. So why? Because as I'm going this way and I'm walking on the graph goes to positive infinity, right? That's right here. But if you are walking the other way, so if you're walking this way at the same time, the graph goes down to negative infinity. So this is where if x approaches positive infinity, f of x approaches negative infinity. Okay, so with that said, I just have to figure out what is my case. Now, my degree was even because it was 6. And my leading coefficient was positive. So if that is the case, even positive, this is that top left corner, I can see that f of x goes to positive infinity, or p of x, whatever you want to call this, goes to positive infinity. Okay, so the next thing that I need to do is figure out what are my intercepts or zeros, also called roots of the polynomial. So here I actually have to remember, so first I crossed out that plus 4, but now I have to take each term, each factor. So I have x plus 4. I also have 4x minus 9, and I have x plus 2. And to determine what 0 that corresponds to, think of setting each of these things equal to 0 and solving them for x. Like, what would happen? So this one right here, you would subtract 4 from both sides, and you would get x equals negative 4. So the factor, like x plus 4, corresponds to the root or 0 of x equals negative 4. Okay, so that's like the opposite, right? So here you would be typing negative 4. Now, to determine the multiplicity of it, look at the power. So here the power for x plus 4 was 3, and that is the multiplicity. So that's going to go here over here. We'll discuss how it behaves in a second. Let's also figure out the next 0. So 4x minus 9 equals 0. If we were to add 9 to both sides, we would get 4x equals 9. And then if we divide by 4, we get x equals 9/4. So that's going to be one more 0 or root. Now, what power? When I look over here, there is no power. Well, that means it's power 1. So this is multiplicity 1. Okay, and then finally the x plus 2 term. So if I set x plus 2 equals 0, then if I subtract 2 from both sides, I get x equals negative 2. So that's my last 0. What is the multiplicity? Well, I look at the power of that factor. So that's 2. So this is negative 2 with multiplicity 2. Now I need to know what is the local behavior. So that's actually pretty easy to understand. If you have a 0 with an odd multiplicity, then you can look at this picture right here. So as it goes through the point, through the 0 right here, it'll switch sign from negative to positive. So it'll cross the x-axis. So any 0 that has an odd multiplicity will cross the x-axis. If it has multiplicity 1, it'll cross it like a line. If it has multiplicity 3 or 5 or 7 and so on, it'll cross it like that, but it'll still cross it. Okay, so any odd multiplicity, it'll cross. So this is going to be cross, and 1 is also odd, so that's going to be cross. Now, for the even, this is what's going to happen as it goes through 0. So it'll just touch or bounce off the x-axis, and it doesn't matter whether it's positive, negative, it'll just bounce off. So this one is where it's going to touch the x-axis. Well, let's take a look and see if we got this right. well, I had to order them. And so that's something that I did not do. So you had to order them from smallest to largest. So beware of that. So actually this one is the other way. This should be touching. So I just messed up and did not think of ordering them. So there is 9/4, and of course is going to be larger. And that one's multiplicity 1, and that one is going to cross. So let's check that out. Now it's correct.